Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 2761, prime pairs with target sum. So in this question, they will give a target n, okay, and we want to find a pair inside an interval like 1 to n, and they both are inclusive. Then in this interval, we want to take two numbers, okay, which will equal to the target when we are summing those two numbers. Okay, can you understand this? So this is what the question, and we want to take such kind of all pairs and return it. Fine. Now let us take this first example. N is equal to 10. Okay, if I give n is equal to 10, we want to find all the prime numbers that gives a pair sum of 10 in the interval of 1 to 10, right? Okay, let us take this example. See here, 1 to 10. Okay, what are the prime numbers? I can say prime numbers are 2, 2, 3, 5, 7. Okay, what is my prime number? First of all, a prime number is something that divides itself and also 1. Other than that, there is no factors, then it is called prime number. Okay, just take for example this 7. 7 can be divided by what? 7 and 1 also. Other than that, there is no factor. But take this 9. 9 can be divided by what? 3 also. This 10 can be divided as 5 and 2 also. Yes, so these are not a prime number, and 1 is not a prime number. Note that point. Okay, now let us take this example. Now from this prime number, which two number can be added to give a sum of this 10? I can say I can add this 3 and this 7. Yes, okay. Now another pair, I can say this 5 and another thing 5. So what are the answers? It is 3, 7 is one pair, and 5, 5 is another pair, right? Okay, fine. So this is what the resultant array should be. That's what the question states. Now let us see the second example. The second example is 2. So what are the numbers that are in the range 1 and 2? Okay, there is any prime number. Yes, 2 is the prime number, but 2 plus 2 or 2 plus 1, nothing can give a target sum as 2. So there is no possibility. That's why we are returning what? An empty array. Can I understand this? Yes. Now what is the logic behind it? Okay, first of all, we can see a brute force approach, a simple approach. Okay, so what is the simple approach? The simple approach is to find an array of prime numbers. Okay, first of all, we want to find an array of prime numbers. Let us take this example as our example. So what are the array of prime numbers? It is 2, 3, 5, 7. Okay, so how to find this array of prime numbers? First of all, okay, first I want to iterate to this all numbers, then I want to take each and every number and check whether it is prime or not, and store in a separate auxiliary space, right? Okay, so let us take this 1. 1 is a prime number? No. This 2 is a prime number? No. 3 is a prime number? No. Sorry, 2 is a prime number and 3 also is prime number. 4 is prime number? No. But how we are finding it? Okay, that's a simple trick. Like, we want to iterate from 2 to square root of a number, and if there is any number that divides the number, then it is not a prime number. Okay, okay, let me take the example as this 9. Okay, so 2, 2, 3. Can 2 divide this 9? No. But this 3 divided 9, right? So 9 is not a prime number, like that. Fine. Okay, so now we have just found the prime numbers and stored in the auxiliary array. Okay, fine. Now the second step is that we will place a pointer here, then I will start iterating to the whole array. So 2 plus 2 is 10, no. 2 plus 3 is 10, no. 2 plus 5 is 10, no. 2 plus 7 is 10, no. Okay, now just take the next element. Okay, now 3 plus 3 is 10, no. 3 plus 5, no. 3 plus 7, no. Then take the next element. So it is 5. 5 plus 5 is 10. Oh, sorry. 3 plus 7 is 10, right? 3 plus 7 is 10. I forgot to say. Is 10. So I will take this as a pair. Sorry. Okay. Now, again, when I come to this 5, 5 plus 5 is 10. Okay. So I will take 5 plus 5. Right? Okay. No. Again, whether 5 plus 7 is 10? No. Okay. Now I finally come to this 7. 7 plus 7 is 14, not 10. So I will stop here, because there is no more elements here, right? Okay, what are the pairs? 3 plus 7 and 5 plus 5. So I will just take 3, 7 and 5. So this is our answer. And note, they are asking us to return in a ascending order, increasing order. So obviously, when I am finding this itself, it is in increasing order. Then here also it will be what? Increasing order only. Okay. Now this is a brute force approach only, not optimized. What is this time and space complexity? Okay, let us discuss about this time complexity. So time complexity will be something like we are just iterating this all elements and also in a loop, in the iteration, separate iteration, right? So it takes up to what? N into square root of n. Okay. So overall it will be O of n square 2. It goes up to O of n square. Okay, what is the space? Space will be, I'm taking this auxiliary space of this prime numbers, right? Yes. So this also takes some space. So let me take the spaces O of n in a rough manner, okay, approximately. Okay, so this is the time and space complexity. Can we optimize it? Yes, we can optimize the time. Okay, how to optimize the time? Okay, so the optimal approach is something looks like we want to find the prime number without a time complexity, with a high time complexity, because here the finding of prime number takes the time complexity, right? Here. So how to find a prime number or not in a range in an optimal way? Okay, let me teach it. See here. Let us take this example. Right? Now listen this carefully. See here. From 0 to 25 I have written. Okay. Let us take n value as 25. And I am asking you to find all prime numbers from 1 to 25. Then this is a trick. Okay. So first of all, we will take an array from 0 to 25. Okay. Basically, array I have in this, right? So it will be size of 26. Okay. We will take plus 1 size. Okay. Now initially assign everything as 1. Right? Now first of all, come here and change this as 0, and come here, change this as 0. Okay, is the first step. First step is to change 0 and 1 as 0. Now come here, 2 is having what? 1. Okay, which means 2 is a prime number. So if 2 is a prime number, then its multiples won't be a prime number, right? So I will go to the two steps. So go here and change this as 0, and go here, change this as 0. Likewise, 8 0, 10 will become 0, 12 will become 0, 14 will become 0, 16 will become 0, 18 will become 0, 20 0, then 22, then 24. Right? Okay. Now going to next. Now I am here. 3 is also prime because its value is what? 1. Okay. So 3 multiples will be 0. Yes. So from here to the 6, already 0. Okay. Wait. Keep it in mind. It is already 0. Okay. Now go to this 9. Make this as 0. Okay. Go to this 12. 12 is already 0. Okay. Go to this 15 and make this as 0. Then 18 is already 0. Then next 21 is 0. Then 24 is already 0. Okay. Just leave it. Now come to the next value. Next value is 4. 4 is already 0. So which means it is not a prime at first place. Okay. Now go to this 5. 5 is 1, which means it is prime. Okay. So its multiple won't be prime. Okay. So come to here from 5 to 10. 10 is already 0. Then 15 is already 0. Then 20 is already 0. And 25 is not 0. Make it just 0. Okay. Now come to the 6. 6 is 0. So it is not a prime. Okay. Now come to this 7. 7 is 1 prime. Okay. See here, 7 multiples, everything is 0 already. Yes. And then come to this 9. Sorry. Come to this 8. 8 is already 0. Okay. Leave it. 9 already 0. Leave it. 10 already 0. Leave it. 11 is 1, which is prime, but it multiplies already 0. So from where we stopped this process? From this 5 we stopped this process. Okay. What is the length of this array? It is 25. So from this we can say we want to iterate from 2 to square root of n. Can you understand this? 2 to square root of n. Okay. Now again, listen this carefully. Inside each and every iteration, see this carefully. When I am at this 2, I started from what? This 4. Okay. But when I am starting from this 3, 6 is already done. So I started from what? 9. Okay. And then come here. When I am at this 5, this 10 is already done. This 15 is already done. This 20 is also already done. Then I came to what? 25 directly. So I can say inside this iteration, another iteration, I started from where? I started from the square value. If I am iterating to I, then here comes what? I into I. I start from I into I. Yes, and I will iterate up to n value, and I will jump what? Up to I value. Can you understand this? If it is 5, then I will jump 5 times. Starting from what? 25. If it is 3, I want to start with 9 and jump to 3. Can you understand this? So this is what an easy approach. Sorry, optimal approach. Okay. Now, what's the time complexity and space complexity? My space complexity will be something like O of here. What is the space I have taken here? It is n. Okay. But what is the time? Time was something like O of n into log of log n. Okay, so this will be the time and space complexity for this problem. No. For this one approach, for finding the prime number only. Now, just take for example, we have got the values what? 2, 3, 5, 7. Okay. Now we want to find the optimal way to find the target sum as 10. So this is quite similar to already we learned a problem called 2 sum, right? Okay, so it is a 2-pointer technique. Let me explain it. First of all, I keep a pointer here and also a pointer here. Okay, fine. Now whether this 2 plus 7 is equal to 10 or less than 10 or greater than 10. So it is 9, right? 9 is less than 10. So where should I move my pointer such that increased value will be there in my answer? So whether I want to shrink my pointer or expand my pointer, obviously expand my pointer. So make this pointer to move here such that 3 plus 7 will be 10. Can you understand this? Yes. So 3 plus 7 is 10. Now giving an answer. So I will take that as an answer. Okay. After taking it, what should I do? I should make a move. I should shrink also, because I'm taking those two values, right? So I want to make this to move front and this to move back. Okay. Now 5 plus 5 is what? 10. Again I will take this 5 and 5. Can you understand this? Okay. So this is I just told you the concept alone. Now in main part it will be something like this. Array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. Here will be 0, 0, 1, 1. Here will be 0, 1, 0, 1. Here 0, 0, 0. Okay. In our main problem, and my pointer will be here and also here. Okay. Now the concept is same. But there's a slight difference. What is the difference? See here, first of all, the value in my pointer is 0. So move here. Again, the value is 0. 0 means what? It is not a prime. That's why I'm moving. Okay. Again, move. Now, here is what? 1. So which means what? It is a prime. So stop here. Okay. Now here also 0. Move here. Shrink. Now it is 1. Stop here. So 2 plus 7 is less than. So what should I do? The same approach. Move here. Yes. Now it is also 1. Here also 1. 3 plus 7 is 10. So take it. Okay. Taken. Expand it. Shrink it. Now here is 0. Okay. Move here. 1. Perfect. Keep here. Okay. Here is 0. So move here. So 1. Perfect. Now 5. So 5, 5, which means 5 plus 5 is 10. I will take it, and what should I do? I should shrink this upper limit and expand this lower limit, and here comes a ending point. What is the ending point? When my lower pointer is exceeding my upper limit, then I should stop. So I stop here. So what is my answer? My answer are these two things. Now let us see the code. See here, prime is equal to 1 into n plus 1. Okay, which means what? I'm just taking an array and each one of them is I'm assigning to 1. I said in the approach itself, right? Now, prime of 0 and prime of 1 I kept to 0 because 0 and 1 are not a prime. Yes. Now, I'm iterating from 2 to n plus 1. Okay, and here you can also mention, like, instead of this you can also mention like 2 to square root of n, right? So in this square root is 0.5, and I will make this as what? Integer value and plus 1, rounding off and plus 1. In range it will be what in Python? N plus 1, right? That's why. Okay, now inside that, if the current value is prime only, then I should iterate to what? I should iterate in a way that I into I. Okay, it's a starting point. Square is a starting point. Then up to n plus 1, and I'm jumping to I. Then I'm making them as what? Not a prime. Okay. Now here comes a method. Here I'm just starting from L is equal to 2. L is equal to 2 because 0 and 1 are not considerable, right? So I'm starting from 2. You can also start from 0 also. That's your wish. Okay. Now result, I'm taking the resultant array as empty array. Then I'm saying the same logic while L is less than or equal to R, which means lower limit should be less than the upper limit. Then I should do what? If my any point, lower limit or upper limit, is 0, then what should I do? I should shrink it. That's what I am done in this line. Okay. Now else I should do what? I want to check whether the sum of lower limit and upper limit value is greater than or less than or equal to the value. Can you understand this? Equal to the target otherwise. Okay, and according to them I am just writing a condition here. What is the condition? If it is equal to, then I will take this as the answer and shrinking and expanding at the same time. If it is less than, then I want to expand the lower pointer. Yes. If it is greater value, then I want to shrink the upper pointer, right? Then at last I will return the result. Can I understand this? Yes. Thank you.